Welcome to the Nordic Venture Show, your speed date with the hottest Nordic innovations and ventures. In this episode, our venture date is with AW Energy, WaveRoller technology, harnessing ocean energy.
Welcome back to The Deep Dive, where we like to really get into the nitty-gritty of things you know. Today, we're diving into something pretty amazing, harnessing the power of the ocean. We'll be looking into AW Energy and their WaveRoller technology.
Yeah, it's pretty fascinating stuff. So to get a handle on this, we've gone straight to the source for this deep dive. We're talking about AW Energy's press releases, all those information pages on their website. We did our homework.
Definitely. The goal is to figure out, how this WaveRoller actually works. You know, it's making waves, so to speak, in the renewable energy world, and we want to see what real progress they're making.
And they've been getting recognized, too. Did you hear about that Earthshot prize nomination they got back in March?
Oh, yeah, that definitely caught our eye. Okay, so first things first. What exactly is this WaveRoller?
Well, in simple terms, the WaveRoller takes the energy from ocean waves and turns it into electricity. The interesting thing, where it works. It's not way out in the deep ocean like some wave energy converters.
So it's closer to shore.
Yeah, much closer, usually like 0.3 to 2 kilometers from the coast. And it's in shallower water, too, between 8 and 20 meters deep.
I see. So not those massive, deep ocean depths. And how about the size? Can one of these things power, like a whole neighborhood?
Well, a single WaveRoller can generate anywhere from 350 kilowatts to a full megawatt of power. Imagine a few of those. That could handle a good chunk of a small coastal town's needs.
That's a pretty decent output. I guess the actual power it makes depends on how rough the waves are.
Exactly. It's all tied to the wave conditions, which means it has a capacity factor of 25 to 50%.
Yeah, makes sense. The ocean's always changing. So do these wave rollers have to work together, or can they be on their own?
They're flexible. A single unit can work for smaller needs. But you can also group them together into wave farms for larger scale energy production.
Okay, got it. So we know what it is and where it is, but how does it actually capture the energy from waves? This is where it gets really cool, right?
It all comes down to what's called the surge phenomenon. Okay, picture a wave way out at sea. The water particles move in a circle. But as the wave gets closer to the shore and the water gets shallower, that circular motion changes.
Because it hits the seabed.
Right. It's like the wave trips over the seabed.
Yeah.
That circular motion becomes more of a back and forth movement. It amplifies the horizontal movement of the water.
So it's more of a push and pull.
Yes, exactly. That push and pull is the surge, and that's where the WaveRoller comes in.
So instead of riding the wave, it's using that underwater movement, like
Yeah.
a door swinging back and forth under the water.
That's a great way to visualize it. The WaveRoller has a big panel that moves back and forth with that surge, like a submerged pendulum powered by the ocean.
I'm picturing it. So the panel moves, but how does that become electricity?
The panel has hydraulic piston pumps attached to it. As it rocks back and forth, these pumps push hydraulic fluid in a closed loop. It's all sealed up tight, so no leaks into the ocean.
That's good, environmentally sound. So pressurized fluid is the key here.
Yep. That pressurized fluid then flows into a system that stores and smooths the power. This ensures a constant flow to a hydraulic motor, and that motor, it drives an electricity generator.
Okay, so it's wave to panel to fluid to motor to electricity.
Hmm.
And how does that electricity get to the power grid from underwater?
Pretty standard setup. It connects to the grid through a subsea cable, like what you see with offshore wind farms.
Makes sense. That nearshore location helps there too. Now, AW Energy talks about the ease of installation being a big plus. How so?
Well, being closer to shore just makes everything easier. It's easier to get ships and equipment in. And you're somewhat sheltered from those really intense open ocean storms, so installation's less risky.
And probably cheaper too, since you don't need those super long cables or crazy anchoring systems.
Right, on both counts.
Mhm.
Now, they also boast about energy capture efficiency, and it seems like their design plays a big part in that.
They mentioned the bottom fixed design and operating in all sorts of sea conditions. Can you break that down?
So the WaveRoller is anchored to the seabed and directly uses that strong horizontal push and pull. That makes it really efficient at capturing energy. Plus, it can operate in a wide range of wave conditions. Some wave energy devices struggle in rough seas or when it's too calm, but not the WaveRoller.
Wow, so it can handle the ocean's mood swings, so to speak.
It can. And get this, it only has one main moving part, that submerged panel. That means less wear and tear, less that can go wrong.
That's pretty amazing. Just one moving part facing the full force of the ocean. They also talk about innovations like the power storage and hydraulic system, which helps create a steady power output.
Yes, those components are crucial. They smooth out the natural ups and downs of wave energy, so the wave roller delivers a consistent flow of electricity that's compatible with the power grid. And another clever design feature is that the inverters are located on shore.
The inverters.
Yeah, those convert the direct current from the generator to the alternating current we use in our homes. Keeping them on land simplifies the underwater unit and makes maintenance a lot easier.
Oh, smart move. Now, let's talk about the environmental side. It's renewable energy, so it's got to be good for the planet, right?
Absolutely. During operation, the wave roller produces zero emissions. And when you consider its entire life cycle, from construction to decommissioning, the emissions are still way lower compared to fossil fuel power plants.
That's the whole point, right? A cleaner energy source.
Yeah.
They also claimed it produces more power per area than wind turbines, which surprised me.
It is quite a claim, but it highlights the density of energy in ocean waves. Water is much denser than air, so waves pack a lot of power into a smaller space. They say a wave roller installation can produce roughly 7 times more nominal power than a wind turbine in the same area.
7 times. That's a lot. It shows how much potential the ocean holds.
Yeah, and because most of the wave roller is underwater, you barely see it from the shore. That's a big deal in coastal communities where people don't want their views blocked. You hear about those issues with wind farms sometimes, but this avoids that problem completely.
Yeah, that's important for people to accept it. But what about the impact on marine life?
AEW Energy claims they designed it with sea creatures in mind. The panel moves slowly and smoothly with the water, unlike devices with fast-moving parts, which could be a disturbance. Plus, everything is sealed tight, so there's minimal noise and no chance of pollution leaking out.
That's good to hear. So where does the wave roller fit in with other renewable sources? Is it competition or collaboration?
It's more like collaboration. You see, waves are a very consistent energy source. Wind and solar are great, but they're dependent on the weather. On average, wave power is about 30 to 40% less intermittent than both.
That consistency sounds really valuable for a reliable energy grid.
Exactly. The idea is to combine wave energy, wind, and solar, creating a hybrid system that can provide a stable and reliable power supply.
So they all work together. Makes a lot of sense. Now let's shift gears to the progress AEW Energy has been making. That Earthshot Prize nomination is a big deal.
It is. It puts them on the global stage. But they've achieved a lot more, too. Last September, the ONDEP project got 19 million euros from the EU. That project is going to deploy a wave roller array in Portugal.
Wow, that's serious funding. It seems like people believe in this technology.
They do. Before that, they successfully finished the EMFF wave farm project, showing they can actually deploy this thing. And back in May 2023, they signed an agreement in Namibia to explore using the wave roller for their clean energy goals.
So they're thinking globally.
Yep, not just limited to one region. There's also interest in the U.S. California's Senate Bill 605 from April 2023 supports studying wave energy, so that's encouraging. And speaking of achievements, they got ISO 9001 certification back in September 2022, meaning they have high operational standards.
That's reassuring to hear. It means they have their act together.
Absolutely. And they're still innovating. In September 2021, they got a patent for a new wave energy recovery system, adding to their already impressive collection of 70 patents. They're also getting into the green hydrogen market, exploring that link between wave energy and producing hydrogen.
Smart move. Green hydrogen's a big deal these days.
It is. And to top it off, they received the EU Seal of Excellence back in June 2020 and got Lloyd's Register certification in January 2020. All this, plus they've got projects running on 4 continents.
It sounds like they're really making a splash, so to speak. Now, one more interesting thing about AEW Energy is their testing process. They have a dry land facility in Finland. How do you test ocean technology on land?
It's a very smart strategy. That facility lets them test the power takeoff units, the heart of the wave roller, under controlled conditions, just like in a factory. It saves a ton of money and time compared to testing everything at sea.
So they're simulating the ocean environment. How's that possible?
They have a special wave machine. It uses hydraulic pistons to create forces that mimic real ocean waves. They can recreate the torque and power levels the wave roller would experience at sea. And get this, they can even simulate the unpredictable nature of real waves using recordings from different parts of the world.
So they can test it against specific wave conditions.
Yep, no matter where they're going to install it. It helps ensure the wave roller can handle anything the ocean throws at it.
That's amazing. They must really speed up development and improve reliability. Well, this has been a really fascinating deep dive into AEW Energy and their WaveRoller technology. It seems like they're on the right track to harnessing wave power.
I agree. From using the surge phenomenon near the shore to that innovative power conversion system and their environmentally conscious approach, the WaveRoller looks like a real contender in the renewable energy race.
And you, our listeners, now have a much better understanding of how this technology works, the benefits it offers, and the progress AEW Energy is making.
Absolutely. It's an exciting time for wave energy, and the WaveRoller could be a major player in the shift towards a sustainable future.
So here's something to think about as we wrap up. We've only just begun to tap into the ocean's vast energy potential. What other amazing technologies might be out there, just waiting to be discovered and developed? Thanks for joining us on this deep dive into the world of wave energy. We hope you'll continue to explore this fascinating and important field.
We certainly hope so too. There's a lot out there to discover.
There definitely is. So until next time, keep diving deep.
And keep those waves coming.
Thanks for listening to the Nordic Venture Show. Don't forget to subscribe and stay tuned for more stories of innovation from the Nordics.